AddMaths2008 Question 11. We've got a graph that's given to us on the paper. The first thing we've got to do is find the value of lambda. So we have the equation y is lambda x squared. Don't let this lambda put you off, it's just a Greek letter standing for some number. But we do know t is the point 4, 2. 4 is an x value and 2 is a y value. So I can actually make this equation here. So I've got 2 is 16 lambda. So lambda is going to be 2 divided by 16, or 1 divided by 8. So lambda is 1/8. So that's the first thing you've got to do in part 1, find that value of lambda. So we now know that lambda is 1/8. So our equation is y is 1/8 of x squared. That will be useful in the next part of the question. In part 2 of the question, we've got to find the equation of the tangent bt. So we know this bt goes through this point here, which will be some x number and 0. And we also know the tangent of that line bt is the same as the tangent of the curve at this point. So the gradient of the curve at that point. To find the gradient of the curve, we differentiate. So we need to find dy dx now. We need to differentiate this. So that's when the power comes down the front, the number stays there, and the power on the x goes down. So it's 2/8, it's a quarter x. Well, at that point, x is equal to 4. So if we do a quarter of 4, we get 1. So we know the gradient of that tangent, which is the gradient of the line bt, is 1. So we know then the equation of that line, bt, equation of a line y equals mx plus c, the gradient of 1, so it's 1x plus c. We know it goes through the point 4, 2. So the 4 is an x number, the 2 is a y number. So I've got here 2 is 4 plus c. Well, c must be minus 2. It's 4 minus 2 is 2. So that equation will be y equals 1x minus 2. That is the equation of the tangent, the equation of the line bt. Next thing we've got to do is to find, we've also got to find the coordinates of point B. So down here, it's on this line, and at point B, its height is 0, so y is 0. So to find point B, just replace y with 0 in there, and you get x minus 2. For that to be true, x must be 2. So B must be the point 2, 0. So now on our diagram, that's 2, 0. I find that out. Next thing I've got to do is find the area of the shaded portion of the graph, which is this area here. So, if I just do a very quick sketch in a minute, we've got a curve and we've got a straight line. There's a triangle here. I can find the area of that right-angled triangle nice and easily. I know that T is the point 4, 2. I know this point down here is 2, 0. So that distance along the bottom, sorry, I'll show you that diagram. I said that point at the top is 4, 2, the point here is 2, 0. So that is 2 on the x-axis, this is 4 on the x-axis. That has a width of 2, that is 2 up, that has a height of 2. So the area of that triangle is half the base times by the height. Half of 4 is 2. So the area of that triangle is 2 units squared. Because if I now find the area of that whole shape and then take off the area of that triangle, I'm going to be left with the area I actually want. And to find the area under a curve, that's when you integrate. So I know the equation of the curve is y is 1/8 x squared. I know the curve on the x-axis starts at 0, and I know this point here is the point 4, 2, so that is 4 along the x-axis. So to find the area under a curve, you integrate the equation of the curve between these two x numbers. Okay. When you integrate, you add 1 to the power, so that becomes a 3, and you divide by the new power. and I've got to do that between 4 and 0. Don't worry, it's a triple decker fraction here. 1/8 divided by 3 is 1/24. Okay, you can just multiply those numbers together. 1/3 of 8 is 1/24. So I've got this 1/24 x cubed. I'm integrating it between 4 and 0. Remember, that means I replace the x by a 4, and then I replace the x by a 0. So I'm going to get 1/24 times by 4 cubed. Then when I replace the x with a 0, I'm going to get 1/24 times by 0 cubed. 0 cubed is 0. Anything times by 0 is 0. The value of that bracket is 0. I'm only going to get something from here. 4 cubed is 4 times 4 times 4, which is 64. So I get 64 divided by 24. That is the area under the entire shape. I can cancel that down. It's 32 over 12. It's 16 over 6. It's 8/3, which is 2 and 2/3. Now, from that area I've just worked out, which is bounded by this, I need to take off the triangle area, which is 2, to get what I want. So the area I actually want is the 2 and 2/3 take away 2. So it will be 2/3 units squared.